Okay, so if you're watching this, I assume you want to learn how to solve Square-1 using the Roux method, which is a faster method than just the plain beginner method. And a couple of things. I assume you know how to solve a Square-1 already. I assume you know how to get it into a square, and I assume you know how to solve parity. If you don't know how to do those things, go watch a beginner video, because this is a more advanced one, although it's a fairly simple method. So, first thing we're going to be doing, basically solving the bottom layer except for these two edges. So we'll be getting 1x3 bar here and here. Then what we're going to do is we're going to solve these four corners. There's only two cases, an adjacent and an opposite. Fairly simple. And then what we're going to do, if there's any blue edges in the top, we're going to switch them with the green edges that are in the bottom in these two places. After that, we're going to solve these 6 edges, starting with these two. There's only two ways these can be permuted: solved or opposite. Opposite is a simple M2, U2, M2. And then we'll solve the last 4 edges, which has a couple permutations, which I'm not going to get into right now. So we'll just scramble it. Like I said, I assume you know how to solve it, get it into a cube, and basically solve a Square-1, and also notation, because there's a couple of algorithms that will be in this video that you may or may not know, because they have certain things that they need to do. So, there. So, we're going to get it into a cube. What we're going to do is we're just going to do this, then we're going to do this, and it's in a cube. So what we're going to do is we're going to build our first block. I usually start with black because it's on this side, and we move this side. So here's our corner, here's our corner. We're going to go like that, match it up, find our edge. Here's our edge. If it's at the front, we know it's going to move to the back if we do an M2. So we do an M2, there's our first bar, see? Put it over there, then we're going to do our second one. So here's our corner, match them up, find our edge is back here. Right there. There's our headlights. If it's at the back, we know it's going to come to the front, so we'll do a U2. M2 solves it. There, in the D layer. So now what we're going to do is we're going to solve the corners. Headlights go on back, /3, -3, /3, 3, -3, -3. There, that's for the adjacent, which is more common. And if you have the opposite, all you do is the adjacent twice. You solve the do adjacent. Here's our headlights. Put them at the back. We do that. Our headlights are solved, or our corners are solved. So what we're going to do is we're going to move the edges in the right layer. This is a very simple case. All it is an M2. But there's a more common case, which is this one. So, which is just one edge. So we put our one edge in the right and in the back. We do 1, 3, 3, -1s, -2, -1, and then -3 that, and then we have double parity. So these two need to go opposite. So M2, U2, M2 is done. Now we have a U perm in top, or a 3-edge cycle. What I always do is I start with our bar on the front. I see this is the opposite one, so I know it goes here. However, if this were the opposite one, which would be this, if this were the opposite one, it won't work. We have to put that over there, our bar over here, so that the opposite one's here. So what we're going to do is we're going to switch these two and these two twice, and it will solve these. You'll see what I mean in a sec. So what we're going to do is we're going to do adjacent, adjacent. So it's -2, 3, -1s, -2, 1. So essentially what it does is it switches these two with these two. I'll show you in a sec. And then so we move those and those. So these two switch, these two switch. So we do it again. And then it's done. So Again, adjacent, adjacent, all it does is it switches this with this and this with this. That's all it does. Fairly short, very simple, easy to use. Comes in handy. So I'll do like an example solve, walkthrough solve, whatever you want to call it, so you can see like my thought process. One thing I should say though is this isn't my main method, so I'm not the fastest at it. You can become quite fast at it with some practice. And I know of people who do use this as their main method. So what I would do is get it into a cube. What am I doing? I'm not doing that. So, first bar, then I see that's there, so we go like that. I see that's there, so that's going to the back. We put it down. Corners are already solved. So edges, that goes there, that goes there. So that's done. Those two are opposite, I think. Yeah, obviously. So N2, U2, M2, D2 to solve it, and we have parities, so we'll solve it using the adjacent one since it's adjacent. However, if it wasn't, I would have used no perm. Middle layer's fixed, and it's done. So now I'll just do a speed solve of it, and I will, these are all just random scrambles obviously, and like I said, I'm not very fast at it, it's not my method, I don't practice it that much, but I still like to play around with it. It's a fun method to do and way to solve a square one. So if I got this muffin paw is how the shape's kind of irrelevant, but still. So cube, first bar, second bar, corners, what am I doing? Edges in the right layer, U-perm, except I'm going to use the faster one, inner layer, or middle layer, fix this thing, and then U-prime, and it's solved, obviously, and 44:15, not a bad time, and as I've said many times, a couple times, you can get quite a bit faster, and that's about it.